All right, so good morning. This is our calendar for the rest of the year. Today starts our last full unit, and this is going to be our last unit test. We are doing 3D figures. It's all about three-dimensional shapes. We're going to be learning about cross-sections, rotations, and vocabulary today. Tomorrow we'll be doing prisms and cylinders. Wednesday we'll do spheres, and then we'll end this with pyramids and cones. And that's going to be all our shapes. We do have a couple things to teach you next week, like composites. Remember, putting shapes together. And we have an assessment review test. So we have about 2.5-ish weeks of this unit. Then we're going to get 2 days of review, and then we're going to have a TEKS test. Remember, you have a TEKS test in every class, every semester. So this TEKS test will be over the entire semester, from January to now. All right, it'll be over transformations, rotating, reflecting. Yep, it's been a while. It'll be over right triangles, Pythagorean theorem, 45, 45, 90, 30, 60, 90, SOHCAHTOA. It'll be over quadrilaterals, rectangles, trapezoids, kites, and then it'll be over circles and area. I don't know, but I don't think any 3D will be on it. But I don't know for sure about that. Okay? Do I have any questions about the calendar? Okay, the week after that is going to be, I think we're going to start probability. We're going to teach a couple days of probability. Talk about what's the probability of, like in gambling. Yeah, what's the probability? Have y'all played blackjack, heard of blackjack? Counting cards, different things like that. We'll talk about that. We'll talk about something called permutations and combinations. And then I think the last 2 days we are reviewing for finals. Then you'll have a Monday off, and then it's finals. Y'all, we're almost there. What's today? I think today means we have 22 days left of school. 22 wake-ups. We can do 22 wake-ups, right? Okay? All right. So if you can grab the notes that you got when you walked in, today's lesson should be quick. We are going to have an assignment in Schoology. You do not have to show work for this assignment, and you should finish it before class ends today, if you're working right. Okay? All right. So first things first, we have some vocabulary words in this little box. What shape is this right here? Anybody know? It's a triangular prism. Correct. It is a triangular prism. All right. And so the triangles, what are those called? Thank you. Say that louder for me. Charles. Bases. So the triangles are our bases. And you can write this right here. A prism is named after the shape of the base. You can tell what the base is based on what there are two of, because a prism always has two bases. All right, does anybody remember what the little point is called in a figure? A vertex. And if there's more than one, or I'm talking about a lot of them, you'll see the word vertices, like you see right here. That's just the plural word for vertex. All right, what is it called, this line right here, all the lines? Edge, yes, a lateral edge to be specific. And then what's the last but not least word that we have not written down? What are we missing right here, this rectangle? A lateral face. For prisms, your lateral faces will always be rectangles. That's actually what makes it a prism. Okay? So I'm going to do the left side with you. What type of prism is this? Rectangular prism. I'm going to use a different color. This is a rectangular prism. Now, rectangular prisms are kind of special because, do y'all agree, all the faces are rectangles? So how do you know which one's the base? Sometimes I'm going to tell you which one it is. Sometimes it'll be shaded. sometimes you're going to get to choose. So in this case down here, do y'all see how that was kind of supposed to be shaded? Can y'all shade that for me? So this is my base. And then this top one is my base. Hello? Yeah. And they were in threes. Okay. All right. So how many lateral faces, or how many bases does this have? 2. So I'm going to put a 2 with bases. How many lateral lateral faces does this have? All the other ones are how many? 4. So it has 4 rectangles around, and those are the lateral faces, the ones that are not the bases. How many lateral edges does it have? Your lateral edges, yep, 4. Connect your bases. Does that make sense? Okay. This prism right here is also a rectangular prism. Oh, this is the same. This is all goes together. Just kidding. This right here is called, do y'all know what this is called? A net. So this is basically, if I were to cut this right here and here, and lay it flat, this is what it would be. In class, up at the front, I have some shapes. If you ever want to use these, you're more than welcome to just to go grab them. I'm going to have them out on the table every day for you. Let me see if I can get this out because somebody shoved this in. Here we go. So here is my personal rectangular prism, and then it has the exact same kind of netting that you see on your paper. So if you ever want to use this to help you, you can. Okay? So for this one right here, how many total faces does it have? Louder? 6. Total faces is 6. And how many vertices? How many points? How many? What? No, total. 8. Because you have 1, 2, 3, 4, but then you have on the other side as well. How many total edges do we see? How many total lines do we have here? We said 4 lateral. 5, 6, 7, 8, 9, 10, 11, 12 total edges. What questions can I answer? All right, you do the next one on your own. Go. I'll give you 30 more seconds. What type of prism is this? What do we got? Somebody, come on. Come on, the longer you gotta take to answer, the less time you gotta have for homework. Thank you. Hexagonal. And if you wrote hexagon prism, that's fine. We just add the AL to make it hexagonal. What? Louder? Hexangular. That's an interesting one. It's wrong. Yeah, hexagonal. Okay. That's okay though. How many bases does this have? 2. All prisms have 2 bases. How many lateral faces does this have? 6. And how many lateral edges? And what do we notice about both of these? The lateral faces and the lateral edges are always going to be what? Equal to the base, the number of sides the base has, right? How many total faces are you going to have? 8. And that's always going to be what? That's always going to be your lateral faces plus your bases. Okay, same thing right here. Their total faces is always your bases plus your lateral faces. How many vertices are there? Louder? 12. And what do we notice about vertices? What do we notice about this number compared to? It's always 2 times the number of sides. Do you agree? Your base has 4 sides, it's double that. Your base has 6 sides, it's double that. And last but not least, the total edges. $18. And what do we notice about total edges? It's always 3 times. Okay? What questions do I have? All right, prisms will always have 2 bases. We're going to talk a little bit later, but what about pyramids? A pyramid is always going to have 1 base. So a pyramid is going to be kind of the same, but 1 base, right? And a pyramid, they're going to have what as your lateral faces? What shape are these? Triangles. So let me see if this pyramid will come out. A pyramid, this is a square pyramid. It's going to have triangle faces. All right. Here's an actual hexagonal, or no, this is pentagonal prism. All right, the lateral faces are all rectangles. Okay, open up, please. What we're going to talk about next is called a cross section. This is probably new to you. I don't know if y'all did this in middle school. Y'all have done a lot of what we're doing today in middle school. But a cross section is when you intersect a solid and a plane. So, do you see this pentagonal prism right here? If I were to saw it right there vertically, do y'all agree? If I saw this right here, what shape am I going to get? When what shape am I going to see when I saw this? So what I want you to think is if you had Play-Doh and it was shaped like this and you cut it and stamped it on your paper, what shape would you see? Say it again. The same thing, correct. If you cut this vertically, you would see the pentagon. Do you agree? But what if you cut it horizontally? What if I were to take this prism right here and I were to slice it right here, cross, and stamp down? What would I see? Not quite. If I were to slice it right here and stamp it straight down, what would the stamp look like on your paper? So in your head, it's Play-Doh. You cut off the top and you stamp it on a piece of paper. What would you see? You said 8. Stamp just the bottom part right here. Not a trapezoid. I get why you say a trapezoid, just because it's getting bigger right there. But what would the stamp be? It would just be a rectangle. It would just be a rectangle. Okay, what about toilet paper? I'm just going to put V and H. Are y'all okay with me putting V and H from now on? Vertically. If you were to take toilet paper, slice it down the middle vertically, and stamp it, what would you see? No. Slice it vertically. If you were to slice it right here, cut it right along there down, and you stamped it on a piece of paper, what would you see? How many rectangles? You would see 2 rectangles, and it would have that hole in the middle between them. All you would see was 2 rectangles. So if you took it, you sliced it, and you stamped it down, you would just see the toilet paper, the white parts of the toilet paper, right? Because of the hole in the middle. So you would see 2 rectangles. What if you sliced it the other way? What if you sliced it horizontally, like this, and stamped it? What would you see? Not a semicircle. A what? What'd you say, Hayes? You would see a donut. You would see a donut. In Schoology, there is, and you're going to play with this when you're doing your assignment. In Schoology, there is something called cross sections. Hold on, let me. In this unit. Cross-section visualizer. And you can go to it while you're doing your assignment. Not right now. Not right now. You should not have your computers open right now. But you can go to it and, like a cylinder, and you can slice it so that you can see what's happening. Okay? But I want you to think, if I slice it and stamp it on a paper, what am I going to see? All right? I want you to try these on your own. What would you see if you sliced it vertically and horizontally? You can describe it or you can draw the picture of it. How am I getting rectangles? Because if I, right here, think about it. If you were to slice this like this, what would you see? Yeah, but you're slicing vertically. Let me get my cylinder. Correct. If you slice this right here, what are you going to see? What do you see from here to here?
So we're not looking at the top, we're looking up.
Correct. You're stamping it down. I see why you're getting semicircle. Okay, let me explain that in the camera.
I thought we were looking at something.
I see why you're getting semicircle. Okay, so look, here's my cylinder. If I were to slice it right here and stamp it right here, kind of flatten it, what would I see? A rectangle. I'm not slicing it right here and then stamping the top. I'm slicing and stamping it this way. Does that make more sense? Okay, glad. Y'all were looking at me like I was crazy. Yeah. So what would this one be if I sliced this cone right down the middle right here? That's vertically. Vertically is cutting it like you saw it in half. Vertically. What are you going to see? That's fine. That's fine. What are you going to see if you put a triangle? And you're going to see a triangle with like the bottom, part of the bottom. What if I slice this horizontally? I slice off the top of the cone, a circle. Is this making more sense now? Okay. The bat's weird. What am I going to see if I slice a bat in half vertically? Shouldn't be hollow, that's illegal, but you're still going to see like the silhouette of a bat. You're still going to see something like that if you flatten it. What if I do this horizontally? What if I cut the bat in half this way? A circle. All right, what about a can? If I slice the can vertically like this in half and I stamp it down, a rectangle. It might be a little rounded at the edges, but I would see a rectangle. And then what if I slice it horizontally in half, a circle? I know it's making more sense to them. What about to everybody else? Is this okay now? Okay. All right, that's it for cross sections. Again, you slice it and then stamp whatever you sliced. Okay? And again, the tool in Schoology is there to help you. If you need it, you just go pyramid. And I think you can change it to go different directions. I also have this right here. This is what my next unit in pre-cal is. What do I have in front of me right now? A cone. This is a cone. And our next section in pre-cal is called conics. So you can do cross sections of cones. This is called an ellipse. What does it look like to y'all? What's that called? Not a circle, but a oval. We call it an ellipse. If you do it horizontally, you do get a circle. And then you can also slice a cone. We're not going to slice it like this. This is, again, pre-cal. But you can also slice a cone. And what shape is this? It's a parabola. So that's what we're doing in pre-cal next. I know y'all can't wait till junior year for that, or senior year. Okay, next thing we're doing. Right side, I'm almost done teaching. When you blank a 3D figure, so I'm going to say when you slice or cut a 3D figure, you get a 2D figure. Do you agree? These cross sections all gave me 2D figures. However, when you rotate a 2D figure, you get a 3D figure. So, I want everybody to look up. I have a sticky note on my pen. Your computer should not be open right now. Close it. Do y'all agree I have a rectangle attached to my pen? Yes. Okay. Pretend this is like paint. If I rotate this around and paint everything that I'm going through, what shape am I creating? A cylinder. A rectangle creates a what? A cylinder. So a rectangle rotated about the line, can everybody put a little rotation about this? Creates a cylinder. Are we all okay with that? Now, what if I were to cut this sticky note like this? What shape do I have now? Okay, same thing. Pretend it's paint and it's going around and painting. What shape am I creating now? A cone. So a triangle up here, rotating around a line, it creates a cone. Does this make sense? If you need to, you just rotate it super fast. What shape? I can't do it super fast, but what shape would it create? All right, last but not least, can y'all guess what a semicircle rotated around is going to create? A sphere. A sphere. All right. And the same thing, if you go into Schoology, there is a section that says rotating 2D to 3D. And you can sit there, look up real quick. Sorry, Miss Weimer's class, I know y'all can't see this, but y'all can play with it in Schoology. You can sit there and play, like, I'm going to make a trapezoid real quick. Here's my trapezoid. All right, look up, please. What shape is this going to create? If it goes around, what is this? It's a cone with what? The top cut off. That's called a truncated cone. Alright, if I did a triangle, what if I did like a triangle, like a quadrilateral? What is that? Yeah, doesn't it? It's weird, right? But isn't it kind of like a cone with a cone inside of it, but cut off? Looks like a cave. So you can play with this and see what happens. If I just do a boring old rectangle, here's to prove that it creates a what? No, rectangle creates a cylinder. And then you can like move it around and see that it's actually a cylinder. Okay, so I'm done teaching for my class. This should be on page 74. As a reminder, if you don't glue in, you cannot use your notes on your final. So here are the pages. If you're a little lost. Again, Miss Weimer's class, you might be different pages. But we're now in a new unit. All right, I'm opening up the Schoology assignment. You can now begin. Go.